Here's the answers to the free response quiz on periodicity. Now, you just have to be careful in how you explain some of these trends. You can't just explain a trend by saying, well, because it gets bigger going up and down a group, or because this increases or decreases going across a period. We need the why. We need to explain everything in terms of attraction. The degree of attraction between the nucleus and the electron cloud is key. And so when I see something like a more favorable exothermic electron affinity energy, resulting in a higher electronegativity, and we kind of mentioned that these go hand in hand, that if you have a high electronegativity, you're more likely to gain electrons, and when you do, you'll release energy. That's the electron affinity energy. It has to do with a strong attractive force. So the attractive force should be stronger in fluorine atoms versus oxygen atoms, even though in reality they both have pretty high electronegativities, but fluorine wins. There's an extra proton, there's an extra electron. You could say there's a greater nuclear charge, meaning the nucleus has that extra proton, so it's going to be more strongly attracted to the electron cloud. Greater Coulombic attractions, thinking about Coulomb's law, in that, in the numerator, it's the magnitude of the charge, which would be the number of protons, the number of electrons. As that increases, the attraction increases. Maybe even the attraction for other electrons in a neighboring atom. So I see the word attraction again. The attraction is greater. Something like B, higher ionization energy, sodium or potassium. This is a group trend, whereas things like electronegativity between oxygen and fluorine would be a period trend. Oxygen and fluorine are in a period going across, where we should mention too that going across a period, there isn't a significant change in distance. The other factor in Coulomb's law, that distance in the denominator is about the same, because we're just filling the second energy level if I'm looking at oxygen versus fluorine. And yeah, the attraction causes the atom to shrink a little bit in size, but it's not a significant player going across. But it is a significant factor going down a group. Going down a group, I'm adding electrons in higher energy levels. So because sodium has electrons distributed amongst 3 energy levels, where potassium has electrons distributed amongst 4 energy levels, well, when the electrons are closer to the positive nucleus, the attraction is stronger. If the attraction is stronger, it's going to take more energy to remove the electrons. And I think earlier we had mentioned too that, yeah, I get it. Potassium does have more protons. It does have a kind of greater nuclear charge. But when you think about Coulomb's law, it's charge over R squared, or like the distance between the nucleus and the electron cloud squared. So when you have a significant change in like the number of energy levels, it makes a huge impact in the degree of attraction between the nucleus and the electron cloud. So going down a group, it's by far the distance that is the factor that affects properties like radius, ionization energy, all that good stuff. The electrons are farther from the nucleus in potassium, so the attraction is weaker. It would take less energy to remove the electrons from potassium versus sodium. Stronger attraction. Distance. Distance is what I'm going to talk about if it's a group trend going up and down. Charge or Coulombic attractions is my bread and butter going across if it's a period trend. C. Now this one is looking at ionic radius. So between chlorine and a chlorine -1 ion, I'm gaining an electron. Well, when you gain an electron, you're going to put it in an orbital that already has 1 electron. And so there's going to be a little bit more repulsion. That greater repulsion is going to cause the radius to be a little bit larger when you gain electrons. Losing electrons would be the opposite. If I lose electrons, like potassium, let's say, if potassium forms a +1 ion, I'm going to lose the 1 electron in the 3rd energy level. So now that 3rd energy level is kind of wiped out. And so now I only have electrons distributed amongst 2 energy levels. So gaining electrons causes a little more repulsion. The resulting ion is larger by radius. Losing electrons, forming a positive ion, would make the radius smaller. And then finally, D, explaining isoelectric trends, right? Did you catch that? That when you've got ions, you have to just double check to see if they're isoelectric, meaning they would have the same number of electrons. Now, if it were like sodium +1 versus potassium +1, well, then they're in the same group going up and down. It's a group trend, whether it's just the neutral atom or they're both forming their +1 ion. Sodium and magnesium are not in the same group, and they do not have the same charge. And so now I see like red flag, this could be an isoelectric series, where they would really have the same number of electrons. They have the exact same electron structure. They both have 10 electrons, a full second energy level. But now because magnesium has an extra proton, that extra proton in the nucleus, the greater nuclear charge, is going to cause a stronger attractive force. So that stronger attractive force would cause the particle to have a smaller radius, and it would also cause a higher ionization energy if I were asked. So again, you can't get full credit for answering any of these explain your choice kinds of questions by just saying, well, because they're in the same group and something increases going down a group, or they're in the same row and it increases going across the row. You're just stating the trend, but you're not explaining the trend. The explanation has to be about attraction. Attraction, Coulomb's law, nuclear charge. Those are kind of your buzzwords when explaining periodic trends.